Hi guys, in this video we are going to learn an interesting question from electrical fundamentals. I have already uploaded some of the videos related to electrical fundamental question. If you haven't watched those, I have given the link in the description. So in that website you can watch all videos for free of charge regarding electrical fundamental things. Also, if you are new to this channel, don't forget to subscribe it. Let's start the question. I have given some information about the questions in the board, so please copy down before entering to the question. Hope you have copied this. Just I'm going to read the question. If you need any clarification, just use the comment section below. The question is, a black box containing series connected elements is supplied by 10 voltage at 20 phase. At omega is equals to 1000 radian per second, I is found to be 2 amperes in 80-degree phase angle. When the frequency of the source voltage is doubled, the current lags the voltage by 45. Find the nature and magnitude of the elements inside the black box. If you have any doubts in the question, just rewind the video and first clearly understand the question. After that, just try it in your own so you will get a practice about this. After that, you can check your answers with my answers. So in this question, they are asking about a series connected elements. Also, they haven't provided what are the elements in this circuit. But the main thing is they have given the details about the phase angle and current in two different angular frequencies. Another important thing is they have asked two questions. The first one is find the nature. What's meant by that nature of the circuit? It simply means what are the elements are inside the circuit. So first we should find what are the elements are in this circuit. In the second part, we need to find the magnitude of the elements. So there are two questions. Hope you can easily figure it out. If you have any doubts, just pause the video and try it in your own. After that only watch the whole video. So I'm going to try the first part. At the first part, they have given at omega is equal to 1000 radian per second, the I is having 80 phase angle. So if I take this as a reference line, I is going to have the phase angle of 80 degrees. Okay, so this is going to be I. But we already know, as it's a series circuit, the I is not going to be changed throughout the circuit. However, if we consider the voltage for every component is going to differ, but they have provided the total voltage we have given to the circuit, which simply means E is equals to 10 voltages at 20 phase. So I'm going to draw that also. So this is going to be the voltage, but I know the angle which is 20 from the reference line. If we consider this, as we all know, the I is leading the voltage. In the previous video also we have talked about that. When the voltage leads the current, it simply means the circuit is inductive circuit, which means the circuit also includes inductor in it. So when we are having this question, we can easily imagine that. So in this case, the I is leading the voltage, which means in this circuit, there will be a capacitance or capacitor. That's why it has been like this. So just remember, if the voltage leads current, we should know there is an inductor in this circuit. If the I or if the current leads the voltage, we should remember there is a capacitor inside this circuit. However, there might be some doubts whether we can tell that there is resistor inside this circuit. However, we all know that if there is only a inductor or capacitor, it might change like this. If there's a voltage, it should be in this 90 direction. As we all know, if the voltage we have supplying is 20 phase angle, so if the voltage is 20 phase angle, the current would be 90 degrees upwards from that or downwards from that if there is only capacitor or inductor. So we can directly tell there will be resistor inside this circuit. So from this data we can directly tell, as it has the I which is leading the voltage, this circuit is functioning as capacitive circuit. As the circuit is capacitive, we can directly tell this circuit contains resistor and capacitor. However, in the second data they have given at omega is equals to 2000 radians, at omega is equals to 2000 radian per second, E leads by I, which means E is leading. Now the voltage is leading I by 45 degrees. So in this case, it's acting like an inductor. As I have already mentioned, at omega is equals to 2000 radian per second, also the voltage is leading the current by 45, we can directly tell this circuit is acting as inductive, which simply means this circuit also includes an inductor and a resistor. From both of these decisions, we can directly tell this circuit contains all capacitor and resistor as well as inductor. So the main thing is this circuit contains all three. So we have found that, but it's not our main task. We need to find what are the magnitudes of that. So in this latter part, we are going to find the magnitudes using simple methods. So in the first part, first we need to find the resistor and inductance, also the capacitance. So we need to find three variables. However, we don't know how many equations we should have. From a common sense, we know that when we are solving the three equations, when we are finding three variables, we need to have at least three equations to figure those answers. So in this case, we need to find any three equations to solve this. If I draw a circuit like this, it's going to be the resistor and the inductor as well as the capacitor in the series circuit. So when we are considering this, first we need to find the total impedance of this circuit. For that, we can easily use an equation because it has a lot of steps. So we need to shorten that steps using these equations, by using these equations directly. So if I consider the Z, the total impedance, it's going to be, as it is in the series connection, we can directly tell Z is equals to R plus omega L minus 1 over omega C whole thing squared. So Z would be R squared plus omega L minus 1 over omega C whole thing squared. But it's not a big deal because we can easily find out that if there is a series circuit, we normally consider the I as reference line. So the voltage would be like this. Also in this direction, the impedance of the circuit, impedance of that resistor would be in this direction. So this is equals to ZR. Also we can directly tell the omega L, the reactance of the inductor, would be in this direction, which would be in the voltage direction if it's connected independently. So if we do that, we can directly tell it's going to be in the Z direction. So if we consider the direction of the impedance of capacitor, is going to be downwards. So it would be omega L, and this would be 1 over omega C. So as it's the square, we don't need to figure out these signs in the initial. So when we are substituting these, we will always get the positive answer. So it doesn't matter whether the omega is bigger or 1 over omega C is bigger. So from that, we can take that if we minus this 1 over omega C, we will get 1 over omega C. We need to find out the resultant impedance. So this would be the resultant impedance we have used there. Pythagoras theorem. Also, we can find this phase angle using tan phi is equals to this value over r. The question is whether we need to find these things. But they have given the voltage, and at omega is equal to 1000 radian per second, they have given the current value as well as a phase angle. So when we are connecting both these two data, we always need impedance. As we all know, V is equal to I into Z. We need to find the value of Z first. So when we are considering this, whether we need to find this angle, yes, we need to find this because we need to get three equations. This would be, if we equate this one, we will having only one equation. So we can directly write V is equal to IZ. From that we can write Z is equal to V over I width. So if we consider this, we know that the V voltage would be 10 at 20 phase angle. Also, we know the value of I, which simply means they have given 2 amperes at 80 phase angle. So when we are simplifying this, we can directly do that by just divide these values, these magnitudes. If we divide this, we are going to get 5. By the way, when we are using these angles, we need to deduct from the first one. So we will get 20 minus 80. So we are getting minus 60. So this would be the Z value. So this would be the Z's magnitude, and this would be the phase angle. So be careful when we are dividing these values. Just first divide the magnitude of that. After that, just deduct from the first one. Deduct the second one value from the first one. As we all know, we have now get the equation for Z using this one, and I'm going to substitute, which is equal to Z 5. So we have the phase angle also. So I need to find the value for phase angle. So it's not a big deal, as I have already mentioned. Tan phi, if I write an equation for tan phi phase angle, it's going to be omega L minus 1 over omega C over this R is equals to tan, be careful about this, tan minus 60. Also, we already know that for this one, the omega is going to be 1000 radian per second. If we simplify this, we can get an answer, but we can get two equations for r squared plus, if we substitute here the 1000 radian per second, we'll get 1000 L minus 1 over 1000 C whole thing squared is equals to 5. And the second equation is tan minus 60 would be equals to omega, which means 1000 L minus 1 over 1000 C over R is equals to tan minus 60. But we have only got two equations, so it's not enough. As I already mentioned, we need to get another equation. So we need to figure out the third equation's data from that question. So in that question, they have mentioned that when the frequency of the source voltage is doubled, the current lags the voltage by 45. So they have mentioning about the doubling of the source voltage, sorry, the frequency of the source voltage. At the time we are having the frequency as 1000. If we double that, we are going to get the angular frequency of 2000 radian per second. So when we are considering the 2000 radian per second voltage, sorry, radian per second source voltage, they have given that voltage, sorry, current lags the voltage by 45. So they are mentioning about the current is lagging the voltage. However, we don't know what's the value of the current because it would change. It won't be similar to the earlier previous one. They have doubled the omega. As it's in depends on the impedance also, the current will be already changed. So we need to figure out how are you going to solve this. But we need to use the data they have given, which simply means a current lags voltage by 45. For that, we can directly use the same equation. Why is that? If we find the impedance of that, it's going to have the same equation, but we need to substitute 2000 for this omega. But they have given that when the current lags voltage by 45. If we find this polar form for that is equals to V over I. As we all know, they haven't given the magnitudes of that, so I'm going to put that xy. If we consider the reference line as voltage, but I'm thinking the current lags the voltage, which means voltage is leading. So if I take the reference line as I, the current, it's going to be 0 and this is going to be 45. So if I divide this, I'm going to get the magnitude of the impedance would be x over y, and the phase angle would be 45 minus 0, which we will get again 45. So here we are going to get an equation by using 2000 for this omega, and it would be equal to tan 45. So if we find those, we will get 3 equations to find all 3 variables, which are RLC. So you can figure it out, but try to use the calculators for solving these. However, here we don't have any complex number equations, but if you don't know, or if you find hard to deal with solving complex number using calculators, just I have already published a video, and also I have given the link in the description, so always you can use it. If you have any doubts, just comment below so I can just read that and answer your questions. I hope this video would be interesting. If you like to watch any other videos, just please consider subscribing. Thank you.